These are the notes for 6-hour math analysis on Thursday, January 22nd. And we have just a little bit to finish and on this section 3-2, and then you'll have an in-class assignment. And just a reminder, homework 2 is due tomorrow, and the quiz on 3-1 and 3-2 is tomorrow. So if you're in Knowledge Bowl and gone on Friday, you'll just take the quiz on Monday. So this last problem is talking about using logarithmic functions and looking at earthquakes and the Richter scale. The Richter scale measures the intensity R of an earthquake. The Richter scale uses the formula R equals the log of A over T plus B, where A is the amplitude in microns of the vertical ground motion, T is the period of the seismic wave in seconds, and B is a factor that accounts for the weakening of seismic waves. Find the intensity of an earthquake with an amplitude of 250 microns, a period of 2.1 seconds, and a B that is equal to 5.4. So for 7a, we're going to say that this formula is R equals the log of A over capital T plus capital B. And A is that amplitude in microns. And in this case, A is equal to 250 microns. Capital T is the period. And for this one, capital T is the period of 2.1 seconds, so 2.1 seconds. And then capital B is just a factor that accounts for the weakening of the seismic waves, and that is given as equal to 5.4. So we're going to use this information and put it in this logarithmic equation. So we'll get R equals the log of A, which is 250, over capital T, which is 2.1, in parentheses, plus 5.4. So take a minute and get that on your calculator. And since it's a plain log, this is a common logarithm or base 10 logarithm. So you can use that key on your calculator. That is the log key. And it has 10 to the x printed on the screen of the calculator. And when you find R, it should be approximately 7 point, oops, I wrote that wrong. It should be approximately 7.5. So the intensity of this earthquake is 7.5. If you need to write anything down, you can pause this. Otherwise, I'm going to go on to the next problem. For 7b, a similar question or problem that we're looking at. So I'll just write that Richter scale formula. R equals the log of A over capital T plus capital B. And for this one, it gives us some information, and it says a city is not concerned about all earthquakes with an intensity of less than 3.5. So there's a concern if the R value is greater than or equal to 3.5. If it's less than 3.5, we're not concerned. If it's greater than or equal to 3.5, we would be concerned. So our job here is to then find the intensity of this earthquake and to decide if we should be concerned or not. So for this one, we'll use those values again. R equals log. A this time is the amplitude of 125 microns over T, which is the period of 3.33. And then that R or B value is 1.2, so plus 1.2. So take a moment and figure out what that is. Again, a common logarithm. So you can just type that on your calculator. And you should find that that's approximately 3.78. So then the questions were, what is the intensity of the earthquake? And should this earthquake be a concern for the city? And yes, it is greater than or equal to 3.5. So um, there is a concern for that one. Now, our next problem involves an equation where we'll have R and we have to find one of those other variables. And I'm going to give you kind of two ways to be able to do this. So this is the same equation again. So 7c R equals the log of, in parentheses, A over capital T plus capital, or in parentheses, plus capital B. So it kind of goes through all that stuff. And then here's where the new stuff is. Earthquakes with an intensity of 6.1 or greater can cause considerable damage to those living within 100 kilometers of the earthquake center. Determine the amplitude of an earthquake whose intensity is 6.1 with a period of 3.5 seconds and B of 7. So the intensity is given to us here, so that is our R value. So in this case, R is 6.1. Um, the period, which is capital T, is 3.5, and they tell us B is 3.7. So it's A that we have to find. We're finding that amplitude, and so we have to find A. One way to do that is first plug these in. 6.1 equals the log of parentheses A over capital T plus capital B, which is 3.7. And there's two methods of doing this, and I'll just kind of go over both of them briefly. So method one is to type this in y1, put this stuff. So log, oh, I'm sorry, I left that t. My bad there. So let me find an eraser that's small enough. That t, I did not put in the value. Um, so that should be 3.5. I'll just make that correction. So in y1, you can type log of parentheses x over 3.5 plus 3.7 in Y1. In Y2, you can put what that Richter scale intensity is. So in Y2, we can put equals 6.1. That'll give you a horizontal line. And then you can graph that and find the point of intersection. Just to kind of give you a hint, I have the graph here, and the window that I used for that or the book authors as well. Here's the window to use from -50 to 950 for the x-axis with a scale of 100. Ooh, let me write that a little better. With a scale of 100. And then the y value should be from -2 to 8 and have a scale of 1. And then you can find the point of intersection once you get that graph by going second, calculate, and intersection, pressing enter 3 times, and then it'll find that. And that's method one. I will show these answers when I'm done, but method two would just be to solve that algebraically. So, and this is something you can do at this point. Sometimes it might not be, so that's why you want to have that graphical method in your mind. But we could take 6.1 equals the log of A over 3.5. plus 3.7 and get that logarithm alone. So my first step would be to subtract 3.7. And when I do that, I get 2.4 equals the log of a over 3.5. Now, if you like seeing your logarithm written in the other direction, you can write that as log of a over 3.5 equals 2.4. And then let's write that in exponential form because you have to be able to do that on your test tomorrow. Remember, there's nothing written as a subscript there, so that means it's a common logarithm or a base 10 logarithm. So we can rewrite this in exponential form as 10 raised to the, and remember a logarithm is an exponent, so the exponent is 2.4, 10 to the 2.4 equals a over 3.5. And then to get a alone, we can multiply each side by 3.5, 3.5, and by doing that, we'll get our value of approximate value of A, or our value of A. And whichever method you choose, I'm going to tell you the answer right now. It's about um, 879 microns. And I think when I did this, yes, I got 879 microns either way. And I will show you the picture here with the intersection shown as well. 879.2 is what it ends up to be there. And so that is the amplitude. So our directions were to determine the amplitude of an earthquake whose intensity is 6.1 with this other information given. So the amplitude of the earthquake, the amplitude is about 879 microns. Now, that is it for this lesson. And so if you would work on, the teacher should give you the worksheet packet, and it's worksheet pages 5, 6, and 12. The answers are on the next couple slides so that you can ask to check those periodically if you'd like. The answers will also be on my YOLA site between today and tomorrow, so you can check those. I picked these pages of worksheet because they are most like kind of some of your quiz questions tomorrow to kind of help you get ready for that. And then you can work on homework 2 as well, which is due tomorrow. So have a good afternoon, and I will see you tomorrow.